Hello, I am Brock Stanton. I am an aspiring meteorologist, and today we are going to be talking about a moderate risk that has been issued across northern and western Iowa, and as well as some of the areas surrounding that. We're not going to cover this risk as much just because it's already ongoing. This risk is going to start very shortly, so we'll be brief talking about this, but we're going to give a quick update on this, see why it's trended towards up to a moderate risk compared to staying at an enhanced risk. But the main story of this video is going to be this fairly large moderate risk that has been added across portions of Arkansas, Mississippi, Tennessee, Missouri, Kentucky, Indiana, Illinois. So a very large moderate risk has been added. We can see that most of this is for significant damaging winds, hurricane force or greater is possible within that hatched area, so that's 74 miles per hour or greater. We can also see some tornadoes and perhaps some significant tornadoes as well. I think especially in this area, perhaps extending a little farther north into this area as well, I do think it is possible we could see the moderate risk for tornadoes extended further north. Not saying it will happen, and regardless whether that happens or not, we're still dealing with a substantial tornado threat and damaging wind threat, so that's not important either way. You're going to be dealing with a significant severe weather and tornado outbreak at this point. So it really doesn't. So a slight categorical upgrade does not matter as much. We are going to be taking a look at the HRRR. We're just going to do a quick update for areas around Iowa. We're going to see that the HRRR fires these storms off very soon. It is actually extremely likely a tornado watch will be issued very shortly. If that has been issued by the time I'm done recording this video, I will try and show it to you. Otherwise, you won't see it, but you just realize it would probably be out by the time you're seeing it. We can see these long track discrete supercells are developing on the HRRR. And this likelihood of seeing a scenario like this is what has led the Storm Prediction Center to upgrade to a moderate risk. So if we're just going to take a sounding in this area, you're going to see it's looping. Here it doesn't develop quite as much CAPE yet. It will as the storms move into the environment. But we could see the long looping hodograph, and it's turning here, and that's what's going to favor these strong long track tornadoes. Again, it only says marginal tornado threat. That's because of this capping inversion here that's absolutely been overcome at this point. So don't let the saying marginal tornado sounding fool you. It's a very significant tornado threat that will be evolving. Just to kind of show this, I'm going to take a look at our significant tornado parameter, and we're just going to see how it really does develop in this area. Again, at 0 is probably not going to be discrete supercells as far south, so it doesn't matter, but we can see how up here where the storms do develop, it's still quite high, and that just kind of overall blends the values of CAPE and shear together and gives you a pretty good idea that there is going to be a significant tornado risk across this area. We will take just a really quick look farther south. We're just going to take a look at the HRRR reflectivity for this. We can see these storms develop. The environment does support large hail to very large hail with discrete storms, and we could see some scattered instances of damaging winds and maybe an isolated tornado threat as well. Something I did realize I forgot to show in the intro. There is a, let's go back to day 1. There's a 45% significant hail for the northern Iowa as well as a 45% wind. So, because of this QLCS that does develop into the overnight hours. Here you can see it there, that QLCS. You can have the potential for all hazards with that as well. Still a strong tornado threat given the very strong low level shear. You can see the looping hodograph. But because it's a linear mode, it won't be quite as significant as these discrete cells in this area. I will say some models try not to evolve this discrete supercell mode, but overall it has still trended more discrete, and it does makes sense based off the overall setup in the atmosphere that we do see at least some semi-discrete to discrete supercells develop ahead of the line. So that's why I was showing you this HRRR solution, because I just think it's a more plausible solution than other models just not firing any supercells out ahead of this line. So we're now going to take a look at the day 2 risk. We're going to first just show what the HRRR does. We can see this morning round of showers. You can see this is 8 in the morning Central Time here, 9 o'clock Eastern. You can see the showers begin to clear out in the later morning hours, and you can see the severe risk is already going to be ongoing with this cluster of storms here. But we can see as we move into the afternoon hours, the severe threat becomes much more robust. This line of storm is going to intensify. You can see there's going to probably be some embedded supercells within this line. That would especially increase the strong tornado risk. It is also likely that clusters of storms will form ahead of the line, carrying a threat of all hazards. While I don't think the environment is going to be the most favorable for discrete supercells ahead of the line, we could still see maybe like 2 or 3 discrete supercells develop ahead of the line. You can see one of them here. There's really a potential like maybe down here a cell becomes more discrete. But if that does happen, that would greatly increase our strong tornado chance. And that greatest chance of happening is where the SPC currently has the moderate risk, and that's why that's the area that has it. Because it's the greatest chance of discrete cell development ahead of the line, as well as the possibility of storms becoming a little more isolated as the line trails south, which means you could get a discrete cell anyway, even like along the line of storms. Or maybe more a broken line of storms if that does develop. And so we can see this line of storms. This is why there's that 45% significant for wind, as well as 15% significant down here and 10% significant areas farther north. But let's take a look at what's going into this line of storms now. We're going to see how this cape develops here, this instability, at least moderate instability. It's going to spread across areas of southeastern Missouri, southern Illinois, really across the whole moderate risk area. And you can see this is the storms using up that instability, and then it perhaps trying to redevelop ahead of that line, but maybe struggling to on this particular run. And that, you can see where our line of storms, it's going to be right down there by 0Z by 7 o'clock Central Time, 8 o'clock Eastern. So you can see our instability is going to be moderate to perhaps strong areas further south. That's also one of our things that's leading to a possibly greater tornado threat, is stronger instability further south. Let's take a look at our 850 jet. Again, very important for assessing our tornado potential. And we can see how when we get into the afternoon hours, we just have this 50 to 65 knot low level jet. And it's for the most part across areas from northeastern Arkansas through western Tennessee and into parts of southeastern Missouri, southern Illinois, southwestern Indiana, how the low level jet maintains its intensity throughout the day, still widespread over 50 knots. But how farther south, it does weaken some. I mean, still strong, 40 to 50 knots is still a strong low level jet, and that's why there's that moderate risk for tornadoes out down here, because, well, yes, the low level jet is slightly weaker, there's a more likelihood of discrete cells developing, so that kind of offsets it. But again, just because the low level jet or 850 jet, I'd use those terms interchangeably. Because it's so strong, I wouldn't be surprised if the moderate risk does get extended north, even if discrete cells don't evolve because of those morning showers. And we're going to take a look at our SRH values now, storm relative helicity. Again, also very important for showing that tornado threat. And we can see how, well, we do get a more localized area of development further south, but they're generally going to be greater further north. And again, that's why there's currently that 10% significant out despite the 1-year storm mode, and I see it always being plausible that some of these areas could be upgraded to a 15% significant for tornadoes despite a 1-year storm mode. Again, regardless, it really doesn't matter because you already have a moderate risk for damaging winds, which is a 4 out of 5 risk. So again, a moderate risk might not sound like that significant, but it is. That's the second highest risk you can be under. And a 10% significant for tornadoes also does suggest a tornado outbreak would be likely. So whether it going from 10% to 15%, while it would increase, again, tornado threat is still going to be high regardless. You can see our 0 to 3 level storm relative felicity, also favorable for strong tornadoes. And we're going to take a look at our lapse rates now quickly. And we're going to see how, our morning round of showers is going to be in this area where they're lowered, right in here. But we can see how into the later morning and afternoon hours, they come back in some. And this is going to be what allows for that destabilization of the atmosphere after the morning round of storms. And it's going to allow for that at least moderate instability to develop, and again, strong instability further south. And that's what's going to lead to our tornado outbreak of storms. Again, severe weather and tornado outbreak, because the damaging wind threat is also widespread. So really, damaging wind and tornado outbreak of storms. There is a hail risk, especially with isolated storms. Could see some instances of very large hail, but overall, damaging wind and tornadoes appear to be the main risk. What I'm looking at now is the bulk shear, and we can see how out ahead of the cold front here, there's going to be these widespread values that are going to be supportive for storm organization along the cold front and ahead of it, which is why I do think we could still see a discrete supercell mature ahead of the line. A couple reasons for that, but that's one of them. However, the big thing that I think is going to limit discrete supercell development ahead of the line is that there's going to be basically no convective inhibition or capping inversion. You can see just basically nothing here. So that can kind of support a messy or 1-year storm mode. But, so again, I think overall we're going to see a messy storm mode and a line of storms along the cold front. But if a discrete cell does mature, the environment is favorable for a strong long-track tornado, or tornadoes, depending on how many of those cells do evolve, though I think it would be only a few at this point. We are going to switch over to the NAM 3K now. We're just going to take a look at what it shows in the reflectivity right now. This is kind of like the future radar of models. We can see this line of storms does develop, and we can see again across this area possibly embedded supercells or semi-discrete supercells with south extent. Again, a strong line of storms. That's why we have our 45% risk for wind out. And it gets this southern mode kind of messy. Like it kind of messes it up. Like it peaks in intensity further west, which is rather interesting. And I think that's because the NAM doesn't weaken the 850 jet nearly as much with southern extent during the daytime, which seems a little weird, I will say, because generally the low-level jet will weaken during peak heating, or during the afternoon hours, so the fact that it barely does that is a little bit intriguing. But we can see how this line of storms does develop all the way further south, but then these showers out ahead of it try and develop, and they kind of just mess up the line of storms for just a little bit. Don't really bank on that. This is a very small scale thing that can't really be predicted upon at all. It just kind of happens. But then you can see how it re-intensifies. So, I wouldn't really bank on that line weakening there whatsoever. We can still see moderate amount of instability, strong shear signaled by that looping hodograph. So, I mean, that still supports tornadoes and damaging winds and hail. So, there's no reason to really think that would happen. And then look at this as the line develops further north. You can see, let's take a sounding here in parts of Missouri. It's looping hodograph. Again, the NAM is stronger with that low-level jet in general. And again, especially with southern extent. So we can see this looping hodograph supports an even greater risk of strong tornadoes. You can see perhaps some more stronger instability, over 2,000 now on the NAM developed, and that, again, that's what would lead to, despite the linear mode, still several tornadoes, and some of those could be strong, even if we don't get discrete cells forming ahead of the line, which is what the NAM shows. It doesn't really show any discrete cells developing ahead of the line. So I mentioned a lot. We just finished playing this through, but I mentioned the 850 jet a lot. Let's take a look at it and see how it is different from the HRRR. We can see how it just looks a lot stronger, just in general. This is 1 o'clock in the afternoon. We now get to 4 o'clock Central Time, and we can just see still very strong 50 to 60 knots. So if this solution pans out, this would suggest an even more widespread tornado outbreak would be unfolding regardless of storm mode. And then as it begins to strengthen into the evening, we can see, again, it grows even more. The line of storms back here, and strong tornadoes would be possible, if not, and I would argue likely, regardless of storm mode, just because the low-level shear is so strong. And again, if we take a look at that, we can see how our shear values are still very favorable for strong tornadoes. Again, they were still favorable for strong tornadoes on the HRRR, but not as much. But that stronger 850 jet helps to keep those values well over 200, even into southern Arkansas and parts of northern Louisiana during the daytime, where we could get those possibly a chance of a renegade cell or two to form ahead of the line. Again, we're going to look at our 0 to 3 now. We're going to see very similar story, all sufficient for strong tornadoes throughout really the entire warm sector. So you saw that. Let's take a look at our bulk shear. And we're going to see how, again, it continues to increase through the day. And overall, this supports severe weather, all hazards. Again, all hazards are going to be possible and likely with this event. Let's take a look at the lapse rates for comparison. I'm curious to see if it does have some greater lapse rates. It does. The NAM does seem to have some greater lapse rates, and I would think with those greater lapse rates, there is likely going to be some more instability. And yes, the NAM has a lot more instability throughout the warm sector. Remember how the HRRR pinched off the instability roughly in this area, but now it extends all the way further north. The HRRR pinched off that 1,000 plus cape around here, extends all the way north, and I think that's because the NAM has much less prefrontal storms, and that allows for the main line to be a lot stronger. Again, down here it does weaken just a little bit. I don't really think that's going to happen, but you never know. HRRR wasn't showing it, and it already seems like a weird thing to happen, so I don't really believe that too much. We are just going to take a look at our surface-based cape and photograph overlap, just so we can kind of visualize on a broad scale across the entire warm sector the threat for tornadoes. And we're going to see how the entire day the photographs are going to be fairly curved. Even further south, they're going to stay curved on the NAM. And with that moderate to strong instability, those type of curved photographs, that's a perfect setup for strong tornadoes. I realize I didn't show that on the HRRR, so we're going to take a quick look at that before we wrap up this video. You can notice how the instability is pinched off much more. You can see the photographs are still curving, but maybe not quite as much with southern extent, just because the low-level jet weakens some. Still favorable for strong tornadoes, given that still 40 to 50 knot low-level jet. but not quite as much as the NAM. So it'll be interesting to see how that evolves, and yeah, we'll just kind of have to watch and see that, because I mean, either way with this setup, we're dealing with a substantial, fairly widespread tornado outbreak, very widespread tornado outbreak. I mean, just look at our Storm Prediction Center tornado probabilities. Our 10% ranges from central Illinois down through portions of Louisiana. So yes, a very widespread tornado outbreak. And again, the low-level shear values are so strong, we could see that 15% significant spread north. Not a guarantee, but my kind of gut says that it does. I don't know for sure though. So I hope you enjoyed the video. If you liked it, please consider liking and subscribing, and I will see you in the next video. Bye.